We always seem to find these rather challenging questions at the end of the chapter, but I think that the carryover we will see later is worth the extra work. So the statement for today's question is, a point charge Q is a distance A greater than R from the axis of an infinite solenoid, radius R, in turns per unit length, and current I. Find the linear momentum and angular momentum with respect to the origin in the fields. Put Q on the x-axis with the solenoid along the z. And treat the solenoid as a non-conductor so you don't have to worry about the induced charges on the surface. Alright, so as always, let's start by defining the fields for the situation. If we have B being in a solenoid, we only have a field inside the solenoid, so that's for S less than big R, where it's mu naught Ni z hat direction, and E is equal to Q over 4 pi epsilon naught script R vector over script R cubed, where script R is equal to x minus A, since we're somewhere to the right of the origin at some location A, Y is Y, and Z is Z. Okay, so then what we need to know is the linear momentum density, alright, which we plug everything in, and we cancel out the epsilons, staying consistent, and what we're left with is R vector cross Z hat. And if we go ahead and take the cross product with this R vector there, what we see is that we have Y minus parentheses X minus A and 0. Of course, the cross product can't be in the Z direction since we're taking the cross product with the Z. Alright, so everything is checking out so far. And if we put this in the hat notation, this is Y hat or YX hat minus parentheses X minus A Y hat. Alright, everything seems to be working. Everything's good to go. Let's go ahead and keep plowing on through then. So the linear momentum is then the P is equal to integral G d tau, and we just have this integral here that is we're going to take several components of it. What we can notice here by inspection is that the X term is odd in Y and will integrate to 0 because we have endpoint start and finish, symmetry cancels it out, so that is nice. And so we only need to worry about the Y component. Okay, so that's why we see on the next page only a Y component. And so we have negative Q mu naught Ni over 4 pi with the triple integral for the spatial integral x minus A over script R cubed, which is x minus A squared plus Y squared plus Z squared to 3s power. Let's tackle the Z integral first. Since we're doing it over all space, we'll go ahead and find dz. After we do that with substitution, we see that negative infinity to infinity yields us back to 2 over square root of x minus A squared plus Y. And if we plug that back in, we see that the momentum is thus with the 2 and 2 times x minus A divided by bracket x minus A squared plus Y squared dx dy. And from here, it'd be best to convert to polar, so we go x equal s, s cosine phi, y equal s sine phi, dx dy goes to s ds d phi, and then we see here we just get s squared plus a squared minus 2sa cosine phi, and we plug that in and simplify it through. We change the order since the bounds aren't limited, and we chug on through. This is very messy, as you might expect, so if we're going to tackle the phi integral, we pull up this form from the table, and you see to the right-hand side, we have 2 pi over b times 1 minus a over a squared minus b squared, and another one, which is d phi, which is a plus b cosine phi is equal to 2 pi over square root of a squared minus b squared. Again, those are found in the integral table. And if we're matching forms, we see that a is equal to s squared plus a squared, and b is equal to negative 2as. So plug them in accordingly to the form diagnoses, and we see here that a squared minus b squared funnels through, and so we're able to take the square root of a squared b squared after squaring everything, canceling, recompacting, and finding a new square form. It's difference of square, or not difference of squares, but it looks like we just refactored that quadratic, hidden quadratic, and we take the square root, so we see that we have a squared minus s squared has to be a real number, so the difference can't be negative, hence the positive root. And we plug that in. Okay, so plugged it into both forms there, and after we split that integral, you see how we plug in both. we get 2 pi over b, which is plugged in red, and then we get 1 minus s squared plus a squared over a squared minus s squared, and then we split up the other integral, so we have a times 2 pi over a squared minus s squared. Now that 1 we're trying to write as a common denominator, so we rewrite that as a squared minus s squared for the parentheses. And since we're factoring out a pi and negative a, what we do is pi over negative a, we multiply the second part of that, the second fraction by another a, so we can factor out that common part and take the minus sign out. All of this is just trying to simplify. It's just algebra, but it can definitely be messy. You see the negative signs cancel after we factor out. The pi's cancel as well. So in the next step, we have q mu naught ni over 2a in the y-hat direction. And now we combine everything to one common denominator. So when we do that, we have to distribute the negative from the parentheses fraction and then add in 2a squared. And we see that the a squared and the minus a squared from the parentheses will cancel. And we're left with this negative 2s squared plus 2a squared. And that 2 can be factored out and will cancel with the denominator outside. So then we're left after that with, once we rearrange the numerator to put the negative second, we get a squared minus s squared over a squared minus s squared. Holy cow, that cancels out nicely. And we're left with just an r integral of 0 to r s ds, and we see that pushes on through to mu naught q and I r squared over 2a in the y-hat direction. Not too bad after you get through the table forms. Now for the angular momentum, we have L is equal to r cross g, so we plow that through with the cross product again. And as you see, it's still messy, so we'll go ahead and push it through regardless, and be very careful with that cross product, because at this point it's going to get nasty and gross, r being some point in space, of course. And then noting that x and y are both odd and z, the negative infinity to infinity will cancel them out. And so all we're left is to integrate in a similar way to p. Okay. So with that, let's go ahead and chug that through then. And we're left with the L is equal to negative mu naught q and I over 4 pi z hat triple integral dx dy dz. Again, only in the z direction because of the odd entries of z. And here we do the z integral as the same. And we, and then we simplify that down, and we get x squared plus y squared over x squared plus y squared minus x over a, and that, minus x over a, all divided by bracket x minus a squared plus a squared, or plus y squared dx dy. Let me slow down. Convert to polar, and you see we can apply the forms that we did last time. Again, just be very, very careful with the canceling. Gets really gross really fast. Simplify it down. Now you see in the fourth step, now again, we're finding common denominators. All good stuff. Let it ring out. We factor that pi out, so we're good there in both terms. Cancels with that numerator. And so the first term after the table integral substitutions gives us 2s squared over a squared minus s squared. Common denominator gives us a squared minus s squared over a squared minus s squared minus s squared plus a squared over a squared minus s squared. All right, let's go ahead, and then again, we're times s ds for the integral sake. And then again, find that common denominator, add the numerators together. We see that the a squareds cancel once again, and we're left with a negative 2s minus 2s in the numerator, which is even better after we factor out the 2 and cancel with the numerator, the denominator outside the integral. And we're left with negative mu q and I y hat, and the numerator cancels to 0. And since that cancels to 0, the whole integral goes to 0, and we're just left with 0. That's nice. We like that result. Zeros are our friend.